In the early 600 BC, a Greek person by the name of Thales first discovered that when amber was rubbed with animal fur, it was able to attract feather and light particles. In Greek, amber is called electron, and that is from where modern terminologies such as electricity and electron originated. Many years later, in the 1700s, Benjamin Franklin, a famous US politician, thought that lightning was interesting and wanted to find out more about it. So, he did something very dangerous that none of us should try. He took a kite outside during a thunderstorm, got the string of the kite wet, put a metal key at the end, and then let the kite float up into the storm. What he discovered was that the electricity from the storm clouds came down the string, and he received an electrical shock. With the passage of time, many other renowned scientists such as Michael Faraday, Thomas Edison, Alexander Graham contributed to the discovery of electrical appliances and paved the way for future scientists to experiment with electricity. So today, we shall learn a bit more about what electricity is and how it works. Hello students, welcome to Notebook. We are back with a brand new video from a new chapter, Electricity. We have divided this chapter into 8 video parts so as to deal with each part in depth. Today, we shall talk about electric charge and current. So what do we mean by charge? We already know that charge is an entity which is defined by either the excess or deficiency of electrons on a body. We have also studied earlier that a body is said to be positively charged if it loses electrons, whereas it is said to be negatively charged if it gains electrons. So the SI unit or the International System of Unit of Electric Charge is Coulomb and is denoted by C. Here, we should also know that when we talk about the charge of a body, we generally mean the integral multiple of magnitude of charge on a single electron. So, the magnitude of charge on one electron E is equal to minus 1.6 into 10 to the power minus 19 Coulomb, and the charge on n number of electrons will be Q is equal to Ne is equal to n into 1.6 into 10 to the power minus 19 Coulomb, and the magnitude of charge on one proton is equal to E is equal to plus 1.6 into 10 to the power minus 19 Coulomb. Hence, we can define electric current as the rate of flow of electrons through a conductor in unit time. Say suppose, we know that Q amount of charges flow through a conductor in time t. Then, we can easily say that the electric current I is equal to charge Q by time t. And as we already know, the Q is equal to Ne. Substituting this value in the previous equation, we get I is equal to Ne by T. Here, N is the number of electrons flowing through the conductor. The SI unit of electric current is ampere and is denoted by A. This name was kept in the honor of the famous French scientist Henri-Marie Ampere. To understand it better, we can say that when 1 coulomb of charge flows through any cross-section of a conductor in 1 second, then the electric current flowing through it is said to be 1 ampere. Therefore, 1 ampere is equal to 1 coulomb by 1 second, or 1A is equal to 1C by 1S. Students, do you know that there are even smaller units of current such as milliampere and microampere? So 1 milliampere or 1 mA is equal to 10 to the power minus 3A, and 1 microampere is equal to 10 to the power minus 6A. Generally, the direction of flow of current is opposite to the direction of flow of electrons in a circuit. So, the current flows from the positive terminal of the cell to the negative terminal. Inside a solid, the atoms are packed together very closely to each other, but the electrons are able to travel through them as if they were in vacuum. When we provide a steady current in a conductor, the electrons in it move with a constant average drift, which is of the order 10 to the power minus 4 meters per second. This flow of charges produces current in a wire. We measure electric current with the help of an ammeter. It is a low resistance device which is always connected in series with the device through which the current is to be measured. Students, now is the time for some little fun questions to help you understand the concept better. Suppose a current of 120 mA flows through a circuit for 2 minutes. Let us find the amount of charge that flows through the circuit. So, what we know is that the current I is equal to 120 mA is equal to 120 into 10 to the power minus 3A. The time t is equal to 2 minutes is equal to 2 into 60 is equal to 120 seconds. So, what will be the amount of charge Q? We know that Q is equal to I into T. Q is equal to 120 into 10 to the power minus 3 into 120. Q is equal to 14.4 C. Hence, 14.4 C of charge flows around the circuit. So with this, we come to the end of our today's discussion on electric charge and current. In our next video, we shall talk about electric potential and potential difference. Until then, take care and goodbye.